Okay, so I'm recording IT386 on January 18. I was just going over the software that we're using, which is Maya, Substance Painter, and Unreal. Although it's very easy to swap out different ones. So instead of Maya, there's Max or Blender. Houdini. Instead of Unreal, there's Unity. Ultimately, you're going to have to know how to use the Sketchfab web 3D viewer and how to post up your models up in here and then post those links onto Canvas. As far as the texturing workflow for Substance Designer into Substance Painter became such an industry standard workflow when the physically based render pipeline became industry standard. So physically based rendering or physically based materials or shaders are trying to recreate physical materials as accurately as possible with our current generation of computer graphics. So this includes the diffuse or the basic coloring of a material. This includes how metallic or shiny, rough something looks. So, for example, this gold bowl is very shiny, it's very metallic, as opposed to something like a cloth or a fabric that isn't so shiny, or they call it more matte, doesn't have much of a reflection. This includes normal mapping, which means adding extra additional relief or detail on top of the 3D model. It's not actually modeled in. And emission, illumination, emission, a light source from within, how emissive, the glowingness of it, radioactivity, light bulbs. Anyway, this is our current standard shader process for like realistic video games called physically based rendering. So Substance Painter and Substance Designer really kind of took that part of the workflow process by storm, and there's I would say that there's not really much replacement. There's a lot of other tools. So this part of the process where you're like developing these really advanced materials and you're somehow painting them onto the model, like 3D packages do have a basic version of this, like Maya and Max have it. The sculpting packages of like ZBrush and Mudbox, I think Mudbox may have come up sleep, but like they have this type of, because they're a sculpting package, like they kind of do this type of painting on a model workflow. But there's no real heavy, competition like this type of, if you do get into industry in these type of workflows where you need to assign like super cool, super high res materials to a model. This type of Substance Designer into Substance Painter is really like the de facto. There is this type of node-based material network in Blender and Houdini, also Maya and Max, but Blender and Houdini are more known for it, where you can get amazing looking materials, and then there's like they have like plugins and exporters where you can like get out what you need to for the game engine. But this type of workflow that's meant expressly to get to the game engine, the Substance Designer, Substance Painter is really kind of taken the industry by storm. So much so that Adobe bought them up. So the problem with Adobe normally is like you can't get free stuff from them, you can't get student licenses. But last year we were. So anyway, the first step. So Cinema 4D and Redshift. Yeah, right. Exactly. There's a million different processes and techniques. I wanted to teach something that I thought was approachable. And that made a lot of sense with industry and that you could use in your other classes and hopefully promote the skill set. So we went with I thought that these three packages were the best, that if you got a basic understanding of how to do the workflow through a 3D content package, to a 3D texturing package into a game engine that you can then use YouTube, our plural site, to really grow yourself outside class. So the point of the class is should have got some previous student work. Example Sketchfab project. Okay, cool. So this is the house that we're going to build for project one. A lot of the students just made it differently. There could be like they made 3 different stories to it. They made like a small little village. They made houses that have like multi-tiered parts to it. In any case, this is the basic structure from the concept artwork. Tall and thin, with this type of kind of like curved roof, and it's from like some fantasy medieval village. And so this is what we're going to build for the first project. This is what a Sketchfab project deliverable will look like from you. But you're building, your material is going to look different. The way that you assemble it. So what students were getting into was you modularly build this house, right? All these parts, these door and the roof and the big major structure, and you bring it into Unreal or Unity, and you build this house from the modular pieces, and the house will look completely different from this, and your materials will look very different. And then there's an exporter out of Unreal and out of Unity. Chris covers the Unreal one, but you can export this like finished 3D model, right? Because you've like built all the parts and you built this much larger structure. You've built it in the game engine, and then you can export it into Sketchfab. Some students like to assemble the whole thing in the content package in Maya and like kind of build what they thought their house or series of houses would be like. And then they exported that whole thing out as an FBX and got into the game engine, and then used the same FBX file in Sketchfab. So there's no one way, there's no right. Again, some students like taking all the parts from Maya, reassembling them in the game engine into their final product, final house, and then using an exporter, a Sketchfab exporter, to bring everything into Sketchfab. Some students like to assemble their final product in Maya, export out an FBX, and use that FBX in their game engine or their Sketchfab. In either case, here's what the final result for Sprint 1 might look like. And so here's the project files to get you going. And so this is me introducing class, and I'm going to go over how to like get the software and stuff. And then this starts off with Chris explaining building in Maya. Here's the software download. So let me make sure these are still correct. Yeah, so the Autodesk website, if you go on this link and you register with your NJIT email, it'll like automatically confirm that you're a student, and you can download Maya, and it'll look like this. I could just press new, and this is what the interface of Maya, the content package, looks like. All right. So next, Adobe. Okay. Students and teachers, get your personal license. Awesome. So it is still free. So we're focusing on Painter. But just know that Designer is the one that lets you build these node graphs to make these very elaborate materials. And then Painter is more for the artist, that it'll give you like a library of substances, a library of materials, and you can select what you wish to paint onto your 3D model. So very similar to painting in Photoshop, although it's not 2D. So you're selecting different brushes, different materials, and you're painting right on the model. And then when you're done with that, you export. So you want to get this one, the painter. And then, yeah, Unity and Unreal. Free. Yep. Just want to get the free one. And I'll check later on. I mean, we don't get into the game engine so much later, but let me check the videos if it's UE4 or 5, and then I'll talk to connect you up on Chris. But it's when you're connecting up assets, nothing has changed in the game engines. All right, so sprint 1, week 2, 3. Okay, so I found from last week that we had to go at a little slower pace than what we originally thought. So if you notice that we have a bunch of lecture videos for week 1, here's your modeling assignment, your downloads, here's week 2. And then we noticed that around week 3, a lot of students start spreading out. A lot of students need time to catch up. And there was too much of a spread in like the progress. And so the questions, what students were talking about on Discord was way too varied. So we gave a week for catch up. Then here's week 4. Here's week 5. Here's the actual substance files that Chris has used to paint the model. And here is the deliverable due date. So basically a month. We have the deadline. So 21. I'm going to correct that. But usually it's like on a Friday or a Sunday at midnight. That's why it says 11:59 p.m. But the actual date. But basically, yeah, 5 weeks, and then you drop what I just found, what I just showed you, sprint 1, and you post up here. It's a discussion forum, so everyone sees it. There's going to be a review process. Basically, we're going to have a class where students can take time to review other people's projects, and then they'll fill out feedback form. I found that the design classes are difficult to grade because I had a talk with a few other teachers about this, and what the issue is that I found to understand is that as you work in industry and you get used to a certain level of work, it's you get removed from the level of work that is good for a student. So it's hard for me to tell what's good and bad for a student because I've just been so removed from that level, level of production. So this is where a lot of students will give feedback on each other because you're at the same level. So we do constructive feedback. Nothing is perfect. Everybody is in a work of art, a work of progress. You need a lot of feedback to understand how to improve yourself. So constructive feedback means pointing out things that could be better, but then saying how to improve them. And if you don't know exactly how to improve them, give suggestions. So you definitely have to be like, well, I like this, but this could be improved, and I would improve this by thinking about doing this or that. So everyone has to get used to some of the hardest things in the industry to expose your work to others. It doesn't matter whether it's code or design. Everyone has that feeling of it's not good enough. They're going to say some bad stuff. I don't feel like I'm ready for somebody to look at my stuff. And it's something you just have to get used to with experience. And you need good, positive experiences to kind of make you, stronger, your work stronger, but to make you receive criticism correctly, to give criticism correctly. So all this stuff in software and games is a team sport. It's not an individual situation. So you need to like talk with other people, get feedback, and because you're delivering something with a team's aspect idea of quality, it's not your idea by itself. You need to understand how to give and receive feedback um, positively and with good vibes or whatever. Um, and everybody is learning and growing, and you wouldn't be taking this class unless you have a passion in it. So help each other and get used to, like, because when you work in the higher level classes and you're on teams or if you're on game jams, anything that you want to clean up and get ready for your portfolio to get you ready for industry is going to involve you working with other people. The more intense, the more pro level, it involves people of different specialties. So I happen to specialize more in programming these days, although I used to really be into 3D modeling, but I just so happens with my progression that I'm more of like an interactive or a game program. So I take in a lot of models and I animate them procedurally, and I'll switch materials and shaders. I do a lot with user interaction on 3D models. Um, and so I work more in the shader code or more in C# or JavaScript side of things. So that's why I asked my friend who works day in and day out in these packages. His workflow is Maya, Substance Painter, Unreal. And so I've asked him to work with me because he does this. This is his bread and butter. And so he's very open. He's very, like, you talk on Discord, he'll be there. I have yet to set up like his hours, but he does work during the day, so he can only be like live in the evening. Although I did ask him, what students found helpful last year was that he would just work on his projects in some of the class time, and students would just sit there and watch. So he's modeling tanks or rifles or whatever for the military projects. And students found it really helpful to just sit there and watch somebody professionally in these packages just working away using the tool sets. And then students would ask questions either in chat or on the microphone. So I'm going to see if he can have some time doing that because I got a lot of feedback that was really helpful. So anyway, this is sprint 1. And then sprint 2, it's the same thing. You need your screenshots, your written description. You need to get something up in Sketchfab to post up. And the sprint 2, we're going to get to. Sorry, I don't have I have to find some examples for Friday. It looks like I didn't get them up, but yeah, I don't have any. Oh, I do have. Oh, I have it as. All right. Well, I mean, it's if I put the. Give me 1 second. See if I should put the concept art up. I must have covered it. This intro. Just look at the syllabus real quick. Okay, this is the concept artwork. This is what you're working on. So it's this type of house. There's this awning. There's a lot of this cargo. There's like axes and picks. These like bells that hang in the front of the house. There's these pulleys and levers and gears. So this is what the final piece looks like. So he first goes into Photoshop and he examines this concept art and he does some drawovers to show you a few things. And then he moves into Maya. Anyway, you'll be assembling something like this. Most students built like a small village and they just imported in like a basic terrain with some trees. But ultimately, we only ask you to just build the house with the props, but assemble it to your liking. But usually students get really into it and they'll make like a little village that they can walk around. So are we supposed to be submitting our progress each week? No, not each week. So that's why the big deliverable is here in this discussion forum. And that's why I need to see screenshots. I need to hear you talking, discussing. If it's easier for you, what you can do is like every week write down, make like a little journal, take a few screenshots and write about what you worked. Students would be like, I got stuck on a few tools here, but I just couldn't get this curved door right. Eventually I gave up. I made it more of like a triangle tip point, but I really wanted to learn how to round it out. I saw how you made the stone materials, but a lot of students are like, oh, I really wanted to make it a more Gothic thing or like a demon house or whatever. And they said, I decided to go with these textures. They might show some references or some concepts. And then they'll talk a bit about working in the packages, and then they'll show the Sketchfab link. And then, so for those 3 sprints, each one is a third of your grade, 33 points. So I'll break that up a little bit. Some of those points are going to have to be for giving feedback to other students. Usually a majority is what your project deliverable is. And then maybe like a quarter of that to a third is your feedback. I'm going to ask you to like give feedback on 500 students. Whoever just joined, I'm just going to mute you because I'm just getting some feedback. But feel free to unmute yourself if you need to ask a question. I am recording this lecture, so I'll put it up later. So take a brief pause. Is there any questions? Is there something that is confusing about what I'm saying? Sure. Okay. So 3 projects. It's all about continuing work on this house. You're not going to make the house and the props all at once. It's going to take you 3 months to make a nice fantasy house with props. And then you assemble everything. And however you wish to do your materials and assemble these structures is all up to you. Obviously, the more creative you are, the more fun you have with the project, the more the other students will have stuff to feed. If everyone just regurgitates the project as is, there's really not much to give feedback on and the grades won't be as good. So just enjoy it, be creative, try to add your own style to it, and just keep track of your work. And you just do this big posting, and then we'll do these little bit of presentations and review session, and people will look at everyone's work and write some reviews, and then we move on to the next project, which is continuing on the house. I think this link is. I want you to join the same. This IT386. So I'll try. Let me see if I can copy it. So in the chat panel, I'll put up this Discord link. If you can try joining this IT386. Everything you see here, this is from, and so these people aren't on this channel anymore. But cool. you can see here that we have a general channel, like Project Help, Unity, Unreal, Maya, Substance, SketchUp. So it's specifics. If you have an issue with a certain thing, you can talk about it. And I don't think Chris is online. I'll leave him alone for right now, because I didn't ask him to join this class, but I'll see when he's available. I'll post up, let me take this link, and I'm going to place the Canvas link on it while I'm thinking about it. Okay, that's updated. So Discord is like, just use it. It's just like going to be like an instant messaging system. It's really useful to just talk, especially in this online nature. So all the sorry, all the lecture videos are up. Attendance is optional. I'll set up situation timing when it's like when I'm going to be on, or maybe Chris will be on, and then you can direct your questions. Again, I'm going to be more the procedural side or the game engine side, and general computer graphics. I need to talk about like what cameras are, and what is 3D computer graphics, and like fundamental knowledge, shaders, or maybe. Yeah, but all the videos are up. Definitely try to get all the software you need installed as soon as possible. And let me just make sure Sprint 2 is up. And Sprint 3. Cool. So I think I covered everything for the class Canvas. And I'm just going to, I'm going to go into Maya a little bit right now, unless there's anyone has any questions. So I'll pause for a minute and let me know. All right. Seems like there's no questions. All right. So every game engine and 3D package has some same essence to it. Let me just shrink this. Anyway, all right. You're going to have a viewport into the 3D world. You're going to have some interface around that. Usually you'll have an inspector or an outliner showing all the objects in your scene. There might be a project view showing you all the external assets you have. There's a lot going on. There's a lot of buttons up here. It can be very overwhelming. There's a timeline down here for animation. You can hide some of this stuff if it's annoying or you can't focus well. But you just can focus up on, there's some major areas that will always be the same. So the viewport is here. Usually there's like some cube gizmo that shows you your orientation. Sometimes you can even move the cube and use that kind of cube gizmo to like rotate around the scene. But normally it's like an alt in left click, middle click, right click, or an option key or a space bar key. Usually some combination like that to move around the viewport. And this is usually like the central area. You have to see into the world to know what you're doing. In this case, if I press the space bar key, I'll get a four viewports. So we got top, our perspective view, our front and side. So if I create an object that's not like perfectly symmetrical, you can see what it looks like at the top, the front, and the side, which happens to be the same. But let's see if I rotate it. a little bit, you can see that the top, the front, and the side are getting different views. So these are known as orthographic. There's no distortion. It's really useful for placement and precision. Perspective view is what you're used to. This is how our vision system works. Things kind of fade off to a point the farther something is. There is like a perspective distortion. So if I like duplicate this thing and move it way off, notice how it's a lot smaller, but it's not really the case. It's just when things are far away, they look smaller due to how our vision works. Usually there's some type of grid and some type of background in the game engine. You might have like a fake world around you. But in either case, it's only what you're creating that ultimately matters. When you click on something, either in the viewport or in the outliner, or liner, sorry. Usually there's some type of properties or channels or detailed information or inspector. Again, there'll be many different names based on the package, but the generalities of it are the same. You click on the name of the object, it gives you a bunch of details of it. So here's translate Z, I'm sorry, translations. And you notice how you can update them here, or you can use the graphical widget, the GUI. You can use the gizmo in here. And so the core, so if you have like a transform in the game engine, these three components will always be there. The translate, the movement, the rotation, the scaling. And in Maya, it's Q key for just selecting, W key for the movement tool, and the E key for rotating, R key for scaling. And notice as I'm pressing the keys that this is the tool over here. So selection, move, rotate, scale. Usually there's like the interface is duplicated functionality. So everything you see here on all these menus, you can also access up here. And there's always hotkeys for everything. There's always like 3, 4, or 5 ways to do something because people have different preferences and other people just want speed or they want access to everything. So anyway, if everything looks really clunky and over the top, you have to realize that it's because there's like 3, 4 different ways to do something. Now, the way that Maya works is that the major parts of the 3D content package are broken up into sections. So you got modeling, rigging, animation, FX, and rendering. We're just focusing on modeling. But if I did switch to, say, animation, notice how these here change, these parts of the menu. So these are like universal. These are specific on the section that you're in. And this here, this like this menu has all the like most popular stuff from all the sections. So modeling, rigging, and animation, but just like a subset, just like the most popular stuff. And then here's some of the more popular elements of this menu. So like these are file, file new, open save, which you can also just get right here. You can also just tear these like little windows off if you're going to use it a lot and park it, or you can close it up and it'll be still accessible right here. In fact, this whole menu, this whole UI, you can really just tear up and pull the pieces off and make a complete mess of, and you can always just reset it. So if you go to Windows and Workspaces, you can reset it. And notice that there's different setups. So this is the general one. You can go to modeling, and this is like what they think a really good setup for modeling is. Let's see, sculpting animation is what an animator might use. And we can just go back to general. This is snapping. So if you don't want to just like freely move something, you might want to use a snapping situation. This is taking renders. This is moving different viewpoint ports. And I think I'm going to ignore the timeline. You don't need to worry about animation. So that's just like looking at the front end of Maya, looking at the user interface of Maya in a nutshell, how to kind of absorb what's going on. Now, I know that that's like, for those of you that are new to 3D, I know this is just like crazy information overload. You're not even going to remember most of that. And the only way you really get to remember it or understand what all this stuff is for is you just start using it. You just start working in the package very slowly. Now you're going to go through Chris's videos, and in 10, 20, or 30 seconds, so he might just be like explaining like a high level concept or something. And you might be like, yeah, it's fine, I can just listen to him. But if he starts using package, he starts doing stuff, you'll find that you're like, after 10 or 20 seconds, like, oh, wow, he did too much. I don't understand what's happening. You're going to have to pause it and then do what he does. So this is the same for software development, for creating computer graphics. I mean, you have to learn by doing. It's all muscle memory. It's all experience. It's like a craft. You can't just sit back and listen. So I remember when I was first learning Maya that my instructor just like went over the whole user interface and absolutely nothing stuck. Nothing made sense and nothing stuck. And it only started making sense until I just started using the application. And a lot of it, I didn't even know what was going on. I just started modeling and then, oh, this menu, mesh. I started using some of these things. So I started to get used to this menu. And then edit mesh. I started to use this quite a bit. And I started to know what a lot of these things meant. And mesh tools never used to actually be a thing. Stuff started to grow and get too cumbersome, and they made the menu, and so on. But the point is that like think of this as like a bunch of toolboxes. Think of this as like if you're a carpenter and like you see all these crazy tools they're using, and you're like, what is all this stuff for? Well, unless you start using it, unless you start like apprenticing under a carpenter, you never get to know what all these different tools are for until you actually just use them on the job. And you're gonna make crappy stuff, you're gonna break stuff, your stuff's not gonna look good. It's just the way it is. So that's usually this is one quote. I don't know if I ever found. I don't even know who this guy is. But he's the only one who had a quote that he's an author or something. That's great. A lot of students found this quote inspirational, and they actually like printed it out and put it on the wall. I'll just give you a minute just to read this. I'm not going to like read it for you. Just take your time and read this. Yes, it's real. Um, Everyone's going to face this, even in programming, which you think is like the driest thing, and it's not. It's a very creative work. And this class is about a creative subject, so it's computer graphics is very difficult. And you're only doing this because you love games or animation or whatever. And you're going to make a bunch of stuff and you're going to be really disappointed and you're going to hate yourself and you just have to deal with it. So this is why the constructive criticism, you need to be honest to people. You need to spend your time and put a lot of critical thought into reviewing their work because they're in the same boat as you. They need that feedback. I still need that feedback. I've been in this industry a long time and I can't do anything without feedback. And so that's real. And so, and people can tell when like you give shitty feedback and you're just like, that's great, great job. And people could tell when you really looked at it and really tried to help them. So that's why it's constructive criticism. You're honestly trying to help them. You have to be honest and to the point. You're all beginners. Everything you make, you're not going to be happy with, but there's like little elements, little potential sparks, whatever you want to call it, of like, wow, if you just, I see where you were trying to go with this, but it just didn't come across. I think if you really do this or that, it might kind of read better, whatever. And a lot of people, not even just in this profession, but many will quit because it's very tough to get past that point. So the more time you put into it, the more honest you are with your peers, the more honest they will be with you. And the better results and the more you'll like work well together, and you might even join up on later classes and like work on projects after school or like even after you graduate. So deal with it is, I guess, what I'm trying to say. And try to keep, the more that you try to like more projects you do, the more you try to understand why your stuff is good, the more you start to understand the principles, design principles. All this stuff is rules and principles, and you'll like figure out what looks good and doesn't look good, and it applies for any trade. So anyway, here's your toolboxes, your tool sets, your carpenter tools, and a lot of this stuff just won't make sense, and over time it will, and you'll reuse like a lot of the same tools over and over and over again. And to be honest, I never learned the hotkeys. So Chris will learn the hotkeys and he'll talk about the hotkeys. But I've always had to like juggle many different packages and I never really specialized in anything. So I always use the menus. And I know when you like really speed up, you're going to want to use the hotkeys or what they call like the context menu. Like I just right click and these things pop up and you can just do stuff really fast. I was always more of a generalist and I turned into more of a programmer. And so anyway, you can only hold so much information in your head and you have to decide what's the most important. So hey, let's see, we have 15 minutes. I'll talk a little bit about geometry, unless there's a question. Okay. So just know that when you leave this class, definitely, if you haven't already, get on the Discord server. And I'm going to start talking about Chris, pulling him back into this class and getting up and going. And he's excellent. You can ask him anything. You can send him projects, and he's like the real deal. And you'll get used to using Discord and everything. So actually, these are interesting to talk about. Why is this? I must have hit a triangulated. Okay, that's good for me to know because I'm going to turn off the grid. So these little buttons manipulate the viewport. Um, and what I want to do is I'm going to select these two and I'm going to turn on wireframe over shaded. So this is just wireframe. There's nothing solid. This is just solid. And then if you hit this, you can see the wireframe on top. So I wanted to kind of, this shows an interesting contrast here. So, I mean, I think first you just start with cube. So you press the F key to focus up on it and rotate. So when you notice how you rotate, you're always rotating around a center point. In this case, I'm rotating around the center of this cube. And notice that these like forces are off on the side and they're like in and out of the camera view because they're not the center point of the camera being rotated. But I can click this one, press the F key, and I can rotate around this thing. And notice now the cube is kind of getting off on the side. So you need to rotate around something. In fact, you actually always need a point of reference to move, rotate, and scale. Now, to rotate makes sense, right? You can see it as the camera is rotating around a center point. And if I parent this object to this one, you'll see it a little bit more clearly. As I rotate this, notice the second one is rotating around its center point, of the other object center point, because it's a child of it now, it's inheriting. So that makes sense. Scaling, it's scaling from that center point. Now this center object, that might not be as visible, but this little side object, notice how he's getting pushed off as he's growing because he's scaling from this center point, which is not his center point, it's off on the side, it's the parent's. But if I take an object and grow it, it grows from the middle. You just don't think that there's a center point that it's growing from. And actually the same with moving. It's not as apparent as it is when you're rotating the camera around. So the gizmo is actually centered up at the object's pivot. So this idea of a pivot is that center point, that point of reference. There always has to be a point of reference in 3D graphics. So, I thought somebody just chatted something. So I think trying to find the second. I just wanted to see where I haven't moved the pivot in this package in a while. My keyboard is like the shortened one, doesn't have an insert key. Oh well. What I wanted to do is move the pivot. The gizmo actually moves off the center point, but moving a parent and its child gets a point across. So so in computer graphics, you have the monitor, which is also called the screen. So you might hear terms like screen space. You have the world, this virtual 3D world, which is termed world space. You have local space. So a child is local to its parent. So you can move the child around, and then you can move the parent around, right? And the parent's moving the child. So this is like thinking about moving world space. And then when you click on a child movie, it's moving within its local space. And then you have this idea of camera space. So just, you're never really gonna use these terms that much unless you get into shaders. But a lot of this is matrix manipulation. Ultimately trying to figure out how to render this object to the screen, to the monitor. To do that, it needs to navigate through its transforms, its matrices, from local space to world space to camera space and finally to screen space. So I just want you to know about these terms. And if you ever get involved in like post effects or having to deal with UIs and they talk about screen space, or when you talk about manipulating hierarchies of objects, specifically character animation is really heavy in it. You might have this idea of local space, rotating within local space. And all these terms are coming from computer graphics, that to be able to figure out how far is the camera. So if I pop off here and I select my perspective camera, and I think you can show it. These are like these special cameras they like never show. So I just pop a camera in the scene. And I pull back a little bit over here. And then let me say panels. I'm going to make this viewing from this. Notice as I move the camera, it's viewing in this viewport. So these objects you can think of are sitting in world space. World space 0, 0, 0 is at the center of this grid. This camera is at a certain coordinate, in this case, -3, 0, 16. X, Y, Z. X is left, right. Y is up, down. Z is forward, backward. What it does to be able to render to your monitor what this camera is seeing down here, it needs to figure out the camera's position in world space, the object's position in world space. It does a calculation, this object in its world space, offset from this camera's world space. It gets now converted into this camera's camera space, which then, however the camera is occupying the monitor, in this case, it's just this little quadrant down here, the camera space gets converted to screen space, which we then can figure out how to render the pixels, because the monitor is just a matrix or a two-dimensional array of pixels. How to shade this torus. Ultimately, I need to know that these pixels right here on this screen, on this monitor, this is where this camera is viewing this torus in this camera's space on screen for rendering that. So anyway, local space, world space, camera space, screen space. And it's very complicated mathematics. And it's all hidden from you. But someday you might dive down a little deeper and have to start to, think about these concepts. But in any case, I'll put this panel back to side, and I'll delete this camera. And now we have a few minutes left. This is a piece of geometry. There's a bunch of primitives that are created for you. It's shaded and rendered to camera in some default way. It has a translation, rotation, and scaling information. And if you right-click on it, you can start to select its components. This is an object, or object level. This is a component level. So this is like the simplest component, or the lowest level component. This is a vertex, a point that has an X, Y, Z position information that you can manipulate. But I start to break the geometry a little bit because it's too simple. This is an edge that connects two vertices. Sometimes it's useful to manipulate this component or model at this component level. Notice that you can rotate an edge as well as move it and scale it, whereas a vertex, you can only move it. It doesn't make sense to rotate and scale it because it's just a point. And lastly is face, or you need at least 3 vertices defining 3 edges. Usually it's 4 vertices defining 4 edges. makes a polygon or a face. And you can rotate it and scale it and do what you want with it. Underneath the hood, you're actually just changing the vertices, which are actually changing the edges, which are just changing the faces, which the object gets rendered differently. Which just brings me to this. Notice how this are just quads, four-sided rectangles. Notice these are triangles. In the history, it was triangulated. So if I select this one, I must have just clicked it by accident. Triangulate. It'll take quads and slice them in half and make triangles. Sometimes that's useful. When you model, you need to stay in quads. Tools will break on triangles, but it's worth noting that when you render to camera, either here in the viewport, here in an actual render, which I didn't do any settings on the render. I don't even know if anything will come out. It's not. But here in the viewport, it's still a render. And in the game engine, it's most definitely being rendered. It has to triangulate the meshes to figure out all of that space conversion I was talking about to get it to render to your screen. So that's the difference of quads and triangles. You keep your stuff in quads behind the scenes, they get converted to triangles. All right, so stop here, watch the videos. So watch my class introduction video. Intro, and then here, we're on week 1. So here's a whole bunch of videos from Chris. All right, I'll see you on Friday. Start talking on Discord. I'll have Chris introduce himself. You're free to go. Hang out if you have any questions. I'm gonna stop recording now. Normally, if anyone has a question, they don't want to be recorded. Unless there's a general class question. Stop recording.